Hello guys, welcome to class 16 of Python programming. Today we'll start object oriented programming. This will be class 1. I hope you are able to hear me. Nibita, Anu, you there?
Yes, sir. Yes, sir.
Yes, I can hear.
Okay, fine. All right. This is our blueprint and this is the class and we create objects. It's similar to or you can write number or even I can write list and then we can create objects. So if I create one object named A, suppose this is one object and this is another object 30, 40. So I created two objects. And the class is list. What type? The type is this. That means A is a list, class of A is list and A is 10, 20. Then we have methods as well. Whenever you create a class, whenever you create one object, it will be some type. We can create anything and we can bring object oriented programming there. So we'll discuss basics of object oriented programming today. So we are in the initial stage. So try to understand how object oriented programming works here. Suppose I write a dot append. This is one method. So this is one method of the object A. The object has some class. Here A is of type list. You consider a human class here. Suppose the class is human and we can create objects. Suppose A is one object, A is Amit, B is Vidyarthi, C is Chinmay. These are objects. They are different objects. A is Amit. Maybe Amit can study, Amit can run, Amit can walk, Amit can talk. B is Vidyarthi. He can only study. He can talk, unfortunately. He has two hands. Similarly, C is one object. There is a difference between A, B and C. C is a girl, suppose, Chinmay, and A and B are boys. So there is a difference. But when you talk about the type, what is type of A? What is type of B here? And what is type of C? All are same type, human type. So what types we know? We know list type, we know number type, we know tuple type, we know dictionary type. Similarly, these are the built-in types, like we have built-in functions. Here we'll create our type. In object-oriented programming, we'll create our type. So Here we have three objects. The names are A, B, C. When we talk about methods, these are functions. In the context of object-oriented programming, we say these as methods. So A, B, C are three objects. You can say instance of the class. See, if you have blueprint of a house, you can construct house like this, 10,000, 20,000, 50,000, whatever number you want. Here, these are the objects. You can say instance of the class. This is one instance of this class. This is another instance of this class. Suppose you want 1,000 objects like this. You can create 1,000 objects of this type. This is a 3 BHK. Suppose you should have a bathroom here, a kitchen here, whatever way you plan. That way you can construct so many houses. These are the instance of this class. The blueprint is the class. The houses are of this type. Whatever you write here, this type. All the houses are of this type. All the people staying in this area are of this type. Or I will not use people. All the, you can say, creatures are of this type, human type. All creatures here in this room, all creatures are of human type. Even you can divide ABC. Men, women also I can write. Suppose A and B are of this type. Even we have to write human, okay, here. And then you write A and B. So these are two objects, remember? So this is a bigger class as compared to this class. Here I've taken only one category. There is another category. So here A and B are of type this. Here A, B, C are of type this. Here the houses are of type this. Here these objects named A and B are of type this type. If you ask me what are these, I will say these are the objects of this type. And when you write append here, we'll study once more what is the meaning of append. We used already in list, but we'll think that way. Now object-oriented way. We'll go to that later, but remember this is a function. A dot append, like I said you here, this object, human object, this object can walk, this object can talk, this object can study, this object can run. These are the functions A can do. Similarly, here A is one object, it has some functions. You can apply append function on A. Functions are methods in class. Two things remember, attribute and methods. Methods means these are the functions. Attribute means data. We write A is equal to 5, B is equal to 7. These are the attribute property. Suppose I talk about A is the object of type this, A is the object of type this, human. A can walk, A can talk, A can play. But when we talk about attribute, we talk about property. A has two hands, two legs. A has a book. A learned. Learning is also A, B, C are objects, and A is of type human. A can walk, A can talk, A can do some task, but A has two hands and two legs. These are attributes, and the functions are the methods here. Let's go back to this. You see animal I've written here, animal class. So these are the objects. one object, second object, third object, fourth one, fifth one. All are objects. There is one here. 6 objects are here, and all are of type this, one type. See class here. These all are of type animal. So animal is the class. These are the instances of the class called objects. How many objects we have? You can count. 6 objects we have. When we talk about the first and second object, you see some similarity and you can see some dissimilarity. Elephant, and you talk about one bird, suppose. There is a difference, right? Elephant can't fly. So the function this object can do, that is specific to this object. And this object can do some other function. I can give you one example. A is equal to 1020. This is one object of type list. We'll go to that directly. Let me complete this. You go here. See attribute here, methods here. So what are the attributes here? What are the properties? The color here, model year, max speed, mileage, whatever given, these are the attributes. And these are the methods. You can say these are the functions. Inside class we say methods. Car can start, stop, brake, accelerate, drive. These are the methods. You can model later. Once you learn the basics of object-oriented programming, you can model anything using OOPS concept. So let's get started. I have to go here. We'll start with a very simple example. We'll try to add 2 numbers using a class concept. Okay, so let's add 2 numbers. Let me write this. This we have to write. Class name is, suppose this is the class. And here also we can write variables like A, B, C, but I'm not doing that. We'll come to this later. You start writing a function here. So calculate, I will write. That is one function. That is one method. If you want, you can give a better name. Anu, you think, if I feel that's a better name, I can give. Okay, here I want to add 2 numbers. So this class name, if you want to change, that's fine. No problem. You can think now. Meanwhile, I'm writing something.
The sum is fine, sir.
What is fine?
Sum.
Some fine.
Yes, sir.
Okay. No problem. Then you have to write like this. Don't worry, just see how things are happening. It will take a bit of time. If you are new, you will be able to follow. Then I can write C Even C also I have to write self.c. Copy here. C, I can write AB. Then I can return this. Now suppose I will create one object. What is the type of the object here? A is of type sum. That means in A you will get sum of two numbers. Maybe I will write X here. X is our first object. This is a simple class. In this class, I have only one method. If you ask me in list class how many methods are there, you can check. Help function or directory function, you can check how many methods are there. I can write like this 10 methods here, 10 functions here. Methods are functions here. So I've started with just one function. The only thing I extra I did is you can do this as a function as well. There you have to cut this line. Then also there will be no self dot a. Whatever goes you just write. No self dot b, no self dot c. See, for everything you need self dot. There is a binding with the variables, the method variables here. Within the class, whatever variables are there, whatever methods you define, everywhere you have to write self. It's a must. It's compulsory. We'll discuss more about this later. Just remember this as self. You can write SEL also, not a problem. But yeah, it's recommended that you use self so that you will be able to understand. Now you have to return self.c. That is C. So now I created one object. You write the name. And then when you create an object, you just write like this. Now X is the object. It's created or not, we'll check, we'll run it. Yeah, there is a problem. Line 2. Okay. This one should be here. Okay, we can keep this one here, not a problem. That means this work, we created the object already. There is no error now. We created this object. The name is sum. It will find sum of two numbers, sum sum. Okay. Now you have to call this function. How you have to call this function? I will write here x dot object dot. Suppose similar to this, I'm creating another object, suppose x is 1020, and then I write x dot append. See the similarity, 50. So what will happen is 50 will be appended to this. So this is the object of type list. This is one object of type this class name is sum. Now what we can do, whatever way we have defined only one method. Here I use append method. That means if you go behind and if you see how the list class is, append must be there in the list class. So how you know X is a list? Unfortunately in Python we don't write such a way. In C programming we write the types also, so that seeing the type you can know. Suppose I write int a, you know that a is an integer. But here there is no way you can know. We don't write. Only seeing this you can say. In other programming language, you need not check this. Directly seeing X, you can say what type. But here, because we don't write type here, we say duck typing. I'll go to this also. There is a meaning, but remember, there is no type. So we see how x, suppose I write x this way, automatically x will be treated one integer. So we don't define here, seeing this one, we decide. So that's why I have to write this so that you'll be able to know x is of type list. List you can compare with SUM sum. Okay. So yeah, here x dot, because we have only one function, one method, we have no other alternative. I can write many things here, append, extend, copy, whatever you had. But here we have only one method. And here A and B, remember, A and B are the numbers we have to input here, give here. Now 25. So what happened here? I created one object. You can create another object. You can create 100 objects here, 1000 objects. What will happen is I can create another object y. I can write y dot CLC, other two numbers. I can write here, I can change numbers. I will get different answers. Okay, that's there. However, let's concentrate here. Self dot a and a, these are two. Whatever you send, suppose 10 will go to a, then a will be assigned to self dot a, b will be assigned to self dot b. Self is compulsory. Suppose you don't write self, then what will happen? See, this method, this function takes two positional arguments, but three were given. Three were given. Where three were given? Two were given. It can take two. Two were given. Not only you are giving two, you have to send the object also, object reference. I will see the ID later. Remember, X, we are sending X also. So when you are sending X, that way you can have binding to the variables here. So self is a must. You can write some other variable, but yeah, it's better to write self. Now it's working. So X will point towards self. We'll check the ID and check whether that is true or not. We are sending not only 10, 15, we are sending this X also here. That way you are able to print. If I want to print a, I can write print a, print self dot a. They will be same here. Also, why this line? This is separate, this is separate. They are not same. Suppose if you want, I can change this to MN. I'll write M here, N here, and then M here, N here, and C. C is different, okay? ABC, ABC are recognized here. ABC will not be recognized outside. So how can you recognize? Through self, okay? So what is the connection between this and this? This ID is also going along with these two values, going to M and N. So what will happen now? See, whatever you are sending, M is 10. So we are assigning self dot a 10 that way. Irrespective of whether M and N are there, self dot a has no connection with M. But in most of the programming, you see they are matching. They will match so that you will be able to write quick. You can remember that way, but it's not necessary. See, now I'm running it. Oh, there is a problem. What is the problem? No attribute M. Okay. Okay, here I have to change because m is there. There is nothing called self.m. Here you see I have self.a, self.b. All right. Yeah, 25. So 10 will go to m, 15 will go to n, id of x will go to self. That way, suppose you want to get a here, how can you get a? Suppose I write x dot a print, or you can write object obj so that there will be no confusion. If variables are there many, you can write obj object 1, object 1, just write object. If you run this one, you are getting 10 here. So object dot this one, you calculate, you are calling this method like append. This is your list, this is your list like a, this is append, this, something like that. And why you are getting 10? Because it will return value. I think you have to write a print statement here. Whatever in return we are getting, we have to print. So 25 we got in return when you call this method through the object, and object dot a is 10 here. Whatever is self dot a, object dot a here, outside object dot a, that's how we send object to self. So whatever object dot a here, that is self dot a here. Now let me write b, you can check. See, I got 10 15, I got 10 15. You print here before adding, I can write print self dot a, then print self dot b. So if you check here, see things repeated 10 15. These two print statements gave 10 15. Then I got 25, the answer here self dot c. Then again two print statements I got here 10 15. So 10 15 10 15, they're matching. If you want to get access to the variables defined within method, you can take help of object, because, and that is the reason we are sending object here, one of the reason. So this is over now. Next go to this one, the difference between right hand side and left hand side. If you try to print m here, because 10 you are sending and 10 m will accept 10, right? You can print it, but try to print this one, or maybe I've written. There is a problem because this has a meaning, self dot has a meaning only after this assignment statement. You are giving this m, whatever you received here, you are giving to self dot a. So if you want to, if you print here, then only you will be able to get the value, not here. So you have to write here. So whatever you send to him, that you can print here, that's available, but self.a is not available. So remember, the only extra thing you are doing here is, in the function definition, you are writing extra self, and everything, all variables will start with self, 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 self.a, self.b, self.c, everywhere. That is the difference. Now, suppose I don't want to send him anything, and I will cut these two. Here I will write 10, 15. This is not required now. And then, yeah, let's run this. I'm getting 25. So it's not that you have to send from outside, even within this also you can define. Now what will happen, because we have sent object here to self, self.a is 15, the binding is this way to a and b, you can print it outside as well. Print object dot a, I can write. Here whatever is self.a outside, that is object.a. Whatever is self.b, that will be outside object.b. Yeah, working 10. If you print here, it's 10. Even we have assigned 10 to this, but you can't write this. If you write this, it will be recognized totally within this. There is no way you can get it outside. If you want, you don't send anything. However, you have to write self dot, remember. Okay, next thing is special method. So what we'll do is, we'll try to write one method instead of this one. We'll write the special method init. Init, here I've written self m n. See the difference. I'll tell you what is init method. These are the special methods in Python. The first special method is init here. Init, initialization. So here let me write mn, or you can write ab as well, not a problem. You can stick to the normal way people write, and everything seems correct. Okay. Now what I did is, I have taken self.aa. So the only thing is, this is called dunder method also. Dunder means double underscore. One underscore here, one underscore here. Most of the time, when people start for the first time, they forget to write one. They think that this is bigger one, not bigger one. There are two underscores here, two here. And this is init. You can change self, you can change this one. This one I will show you in the next class. This is present everywhere because this is initialization, not mandatory though. Now I'll do the same task using init as well. I'll do the same task using init as well. How? What is the usefulness of this method? This method is normally used to initialize the variables. We are not supposed to do any function, though we can add here, that's a separate thing. But yeah, difficulties will come, I'll tell you. This is not sufficient. Even this is not necessary, but you will see later, almost in all cases, you have to take this one. So ultimately, you see, you feel that this is necessary, but this is not sufficient. You need lot of methods. This is initialization method. This is a special method. Automatically, variables will be initialized. How? Self.a is a, self.b, b is b, then a, b, I added c. If you run this one, it will, again, there is no calc function here. So I can write, see, the whole represent the name of the function here. 2 underscore init 2 underscore. This is equivalent to CLC. I got CLC. CLC is the name we have given. We could have given any other name, but here this is constant. This is special method. There are many special methods. We'll use some methods in our classes. The first special method is init init. Now, will not specially call this function. This is automatically called. That's how it's special. How functions are special, I will explain whenever I use some function. This is special. Here, you need not call this way, like append for list append method. We are calling that by writing dot. When you write numpy np dot add. Now, again, object, this is the numpy object, you can say, and this is one method. Okay, when you write list dot append, this is the method, this is the object. Now, so wherever you see dot, that means there you are applying a method, a function. So here this is the special method init double underscore both the sides, that is called dunder method. And unfortunately it can't return certain things. You need to remember, in Python the initialization special function is constructed in such a way that it can initialize the variables, it can return something. Okay, so instead I can print it. Print is like 1%, return is like 99% or 100%. Okay, I will show you the difference. It can return anything, you can print whatever is there, it will print, that's all. Suppose I have a book, I will show you, I will not give it to you that way. Video I will show you from here. There are many institutes, they do that way. You can watch videos, you can download, you can take it. So whatever is there, it's showing you. Similarly, we are just printing here. We can print here. We can't return this one. Okay. So now I can run it. I'm not calling also. I'll not call anything. I've created an object, that's all. Automatical thing should act. Whatever you have written, check it. There is error, we'll sort it out. Yeah, missing two. Okay. Now, because we will not call any such function, the A and B you have to give here. Run it. Now 25 we got. So you might ask me if you can do using init method, you can initialize. There even we initialize. Here we have added. There even we have added. Here we have printed. There we didn't print. So if you want to add two numbers, multiply, subtract, divide, whatever simple operations if you want to do, that you can do here. But this has a limit. You can do only within the function. You can do it outside. That's the problem. If you can do it outside, then it has limited you. Suppose I got object, then I want to use this one somewhere. I want to know what is the value of obj plus 100. Okay, it will not work because I'm not getting anything in return. Where I will get, because we are not calling any function. See, I'm repeating, remember, this is very, very important. I'm not calling this function init. I'm not writing object dot obj dot init. I'm not writing this. I'm not calling this. Writing 10 and 15. I could have done that, but I'm not doing this. I'm not calling. So this will be automatically, whenever you create an object, automatically this will be called. You need not call it specially. So now without only at least this small program, when you wanted to add two numbers, you are able to do that by both the methods, by using init and by using a method, our own method, not the special method. Special methods are there already. we have to use our own methods. The disadvantage here is, in return you are not getting anything. You can only print and you can show. That means if you printing is nothing, okay? Printing is nothing. So what you can do, you can only initialize 10, 20, 30, whatever variables are there, you initialize. And simple operations like you can add, subtract. Even if you add, how useful it is when you are not able to return, how useful it is, it's not useful. So again you can forget about this, not useful, leave it. How useful if you are not able to return? So ultimately, to initialize the variables, you can use this one. Now let's go back to the other one, CLC. We have done that, our own method. We have to call though. Oh, this much, no problem. I can write CLC once again, and I'm calling. Yeah, every other thing is fine. Yep, I can run this one. What problem it shows? Okay, 2 mn self I've written. So here, because when I created the object, the name of the object was obj, that's fine. Because there is nothing to initialize here, this is directly a function. So I have to send here m and n, okay? So 10, 15, if I write, I will get the value, okay, 25. So I'm getting something in return, I can print that. I'm not printing here, see, I'm returning here. That one I'm printing here. So what I can do is I can store it somewhere. Suppose I will store it here. Now I can use it. Suppose I want to print 100 plus I'm showing you the simple use. See, 125. So because I'm getting in return, whatever you are getting in return, when you write this object.clc 1015, I'm getting something in return. Whatever I'm getting in return, that I can use further, because in it's stored, the sum of the numbers is stored in so I can use this way. That is the benefit. I could have written print here, that would have been different. If I write print here, even here there will be a problem, because if you print forget about printing this. If you print what you get? None you get. Because when you call, remember, init never called. If you don't call this, it will not do work for you. We have to call this function. Init is a special method. You are not calling, you have to call this function. So what happened is I called that function and I've given values here, and then m and n. Oh, then what is the use of that? Okay, so 25 I got, because when I called this as a part of the work, it showed the value. That's how I got 25. But I wanted to print it printed in there is nothing, that's why none. Why there is nothing? It's not returning. If it not return, what will be stored here? See, as a part of the work of the function CLC, it's printing. It's there, that's why it's printing, but it's not returning anything. So this is a very, very stronger one as compared to print. Print is nothing. It's like whatever money you have, you are seeing whether that's there or not. So if you return it, you store somewhere, you can print it. You get 25. But when you create this object and when you store this one, you will not get it, because the instruction, when you call this function CLC, the work was to return, the work was not print, so it returned. We saved here in then we want to print that, we are getting 25. So you can use further later in your program, whatever you write. So you see many in many places written rather than print statement. Now what we'll do is, instead of writing either our own function CLC or using INIT, we'll make a combination that will be permanent one. So the standard is, whenever you initialize, also we'll go to the normal standard. Let's change everything and write AB here. Then this one is there. Let me copy, and whatever work function I want to do, I'll do here. See, whatever function I want to do, I will do here. Okay. And this one for initialization, I will use INIT. Okay. So this is the name of the class. Even this looks odd. So we start with this name of the class. Then the first initialization function, make it a point to write this way all the time. This looks good. Now, two functions here. One special function, special method, you can say, class method. And the other one is our own defined function. We say method here in class CLC. And AB are required or not, that we have to see. AB are no more required here, because we are, when you are creating this one, you have to write now 1015 here, because all initialization work we have divided it differently. The task is given whatever way, that way it will perform. So when you create an object, whatever variables you want to initialize, you send here while creating the object. Okay. So this will be final. You have to remember this way. Use INIT and then create the object. Okay. And all the variables, whatever you send here, you might need more, that's a separate thing. But yeah, you send all here. Then here there is nothing, only self. Okay. And then you return it. Okay. So this is better. Then I created the object. The name of the object is obj, and this object of type this. Okay. And we created already. Then what we'll do is, you have to call this. Let me run this one. What will happen? It's not a mistake. There is no problem anywhere if you watch. However, we didn't get anything as well. We didn't get anything in return, because this is automatic. Even I could have written print here, print self dot a whatever. That's fine. But yeah, I mean, this is only for initialization. This is for some work like adding, multiplying, subtracting, whatever. We have divided now, so that there will be no problem in future when you write 10 lines here, 5 lines here. Okay. This is initialization. We initialize everything. And here, this one you have to call. So let me call this obj dot. Now I need not give any value here, because I've already created using 1015 here, because now I separated. Okay. Instead of using this or this, I showed you how to add two numbers using only this, then using only this. Now this is the best one combination. We'll continue this way. Whenever you create object, whatever variables you want to initialize, you give here. Here you are supposed to call. If you need some other thing, you can give here. That's a separate thing. But whatever I know by now, okay, if you know time at the time of creating the object, you send everything. Okay. Now Let me run this. Yeah, 25. This is what you need to write. The whatever variables we have here, self.a, self.b, these things again I'm saying, don't worry about a and b. A and b are the ones you sent here, and now they stored here. The scope of a is only within this. Okay. A you can print here, you will get. Suppose I write print a here. Yeah, you got 10. Now see, at different places I will try to print. Cut, try to print here. Written, before written I have to write. You print here and you check what problem it says. A is not defined. See, this is, although this is a special method, we say this is a method, this is a function, this is a function. This A is not available here. This A is even class data, class variables also we have. We can write something here. I'll go to that later, but it's not available. However, if I write it self, is it available? Check it. Yes, it's available. That means from one function you can go to the other function. From one method, I mean, when you initialize these things, you can use self.a, self.b everywhere. Not only within this function, this method, here also you can use. Now let's take it and write here. Check it. There is a problem, right? Self is not defined. But what you can do is, you cut this. A is equal to 5. Print A. Okay, I have written A now. I can write T is equal to 5. Print T. You run it. Print T I have written, right? So yeah, I got it 5. So I printed this T here. I got it. This is called a class variable. This is a class variable. Okay. And this I got here. This I got here. Now this class variable T is common to all the objects. Whatever objects I will create, it's common. I will go to that. There are different kind of variables. Now my question is, if this is a class variable, can you get that one here? Suppose this is initialization, you forget about this. I want to print here T. Is it available? In this function I want to print T. Check it now. It says T is not defined. Now you write print.t. Sorry, self.t. Yeah, it's available. So if you are wondering how this T came here through self.t, how? Because when you created the object here, see, sum is here, this class is here. So class variables also you can access here by writing self. So how useful is self? Through self. So when we write self here, see, self thing started here. Okay. So whatever you want to, wherever you want to use the variables, you can use freely. Remember, you have to write self. That's why we initialize all the variables here. and using self we write. Now, outside the class is over here, okay? Class is up to this. This is outside the class. Object is not inside the class. Object is outside the class. Whatever you have, all are inside the class. You see, there is an indentation. So once you come here means you are parallel to this, okay? You are the same to class. So you are outside the class now, and you created the object and you applied method like append. This is a method, and we got the answer. And then I will tell you next time how to use variables like this, these variables, the class variables, effectively and when it's needed. Okay, that also I'll discuss. So now forget about T. We'll make it simple. And the benefit of object oriented programming is this. If you ask me, normally what we do is this is your procedural programming. A is 5, B is 10. Then we define a function, and then whatever we write here, then define other variable, then another function. So if you check here, the function, the functions and the variables, they're separate. There is no connection. Okay. We say all the variables you define here, they are only available within the function. These are not available inside. Okay. This is not available inside. Inside thing not available outside. What is the change here? I'm talking about the basics. Later you will be able to know and apply in different situations. Here you should know this one within a class, this one will be there, and this one also is there. Sorry, this one is also there. So now this total is called a class. Within class we have variables available. Suppose I saved 5 crores. I don't have, it's another thing. I saved 5 lakhs. I saved 10 lakhs. Okay, or maybe my name, whatever I've written. These are within the class. So what happens is here what will happen, these are available outside the function. So there is a problem. So when you go to the bank and you withdraw some amount, withdraw is a function. You deposit is a function. And whatever amount you have, this is the data. The data is there within the class. Okay. You can't, like, it's not available outside. Whenever you call, you check, okay, check balance, withdraw, you deposit. That way what we do is we try to call the functions and we get the answers here. Okay, your this amount is deposited, this amount is credited, finally of this amount, all this we get. So we have a lot of properties. We'll go to those things later, from class 1 to class 2 3 if required 4. But yeah, initially whatever I wanted to complete today, I just wanted to add two numbers to start with, and we're successfully were able to do that within with the two functions, one initialization function and the other one is this one, CLC function. We'll do more next time, and we'll try to learn from class to class. Probably if you want to do properly, it will take 4 classes rather than 3. Yeah, class is over for today. Thank you.
Thank you, sir.
Okay,
Thank you, sir.
anything you would like
Good
to
night.
ask? Yeah, maybe
Nothing,
later,
sir.
huh? Yeah,
Nothing.
okay. Okay, all right, thank you.
Yes, sir.
Yeah.